Good afternoon, students. So today we are dealing with the third topic, that is current electricity. Okay. So in the current electricity, we will discuss about. Okay, 1 second, Jyoti. I want to ask you, that is from which college you are. Yesterday you told me to add in the group. So in the chat box, you just tell me your college name so that we can add you. Okay, let us start with the class. So current electricity. So in the current electricity, we will deal with what is electric current and discuss ಮಾಡ್ತೀವಿ. Then we discuss that is current density ಅಂತ ಇದೆ. Then we have the drift velocity, mobility is there. Then conductivity, resistivity, Ohm's law ದಲ್ಲಿ resistance ಅನ್ನ study ಮಾಡ್ತೀವಿ. The factors affecting the resistance, the resistivity, on what factors the resistivity depends. Okay, so that is the resistors connected in series and resistors connected in parallel, that is deleted for the academic year. So adanna bittu we have the cells, EMF study ಮಾಡ್ತೀವಿ. EMF ಆಗುತ್ತೆ. Then after that we have cells in series, cells in parallel. Yes. Okay, correct. Then after that we have the last part, that is the Kirchhoff's laws we will discuss. So Kirchhoff's laws ಇದೆ. Then Western network is there. So these are the content of your current electricity. ಹಾಗಾದ್ರೆ ನಾವು ಕ್ವಶನ್ಸ್ ಅನ್ನ ನೋಡೋಣ. ಅಲ್ಲೇ ರಿಲೇಟೆಡ್ ಯಾವ್ದಾವ್ದು ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ ಅಲ್ಲೇ ನೋಡ್ತಾ ಹೋಗೋಣ. ಓಕೆ, ಸೊ ವಿ ವಿಲ್ ನಾಟ್ ವೇಸ್ಟ್ ಮಚ್ ಟೈಮ್. ಲೆಟ್ ಅಸ್ ಬಿಗಿನ್ ವಿತ್ ದ ಕ್ಲಾಸ್. Yes, so here you can see the first question, students. That is, the current density varies with radial distance r as J is equal to AR square. In a cylindrical wire of radius r, the current passing through the wire between the radial distance r by 3 and r by 2 is. So question meaning artha madಕೊಳ್ಳಿ first. What is the meaning here? See what they are saying. The current density varies with radial distance r as J is equal to AR square. So J ಅಂತಂದ್ರೇನು? J ಅನ್ನ ನಾವು current electricity ಅಂತ, current density ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ನಿಮಗೆ ನೆನಪಿರ್ಬೋದು, current density is given by what? Current per unit area. It is current per unit area. Okay, then in a cylindrical wire of radius r, then the current passing through the wire between the radial distance. So between the radial distance, the current flowing through the wire is given by anta kelta idare. Okay, so let us calculate this. Yes, so already the current density in the question itself, it is given J is equal to AR square anta question al kottidare. Hope so you have copied the question. So the current is given by what? That is JAR square anta question allide. Then after that, here you can see what we need to do anta andre, we need to integrate the equation. Yakanta andre aden aagta ide, the current is varying between the radial distance, that is from r by 2 to r by 3 ಅಂತ, ಅಲ್ಲಿಂದ ಅಲ್ಲಿವರೆಗೆ ದ ರೇಡಿಯಸ್ ವೇರಿ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ, ಸೊ ಈ ಇಕ್ವೇಶನ್ ಅನ್ನ ನಾವ್ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ದಟ್ ಇಸ್ J is equal to integration of J into dA with respect to area we are integrating this. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಲಿಮಿಟ್ ಏನ್ ಬರುತ್ತೆ, ರೇಡಿಯಸ್ ಯಾವ ರೀತಿಯಾಗಿ ವೇರಿ ಆಗ್ತಾ ಇದೆ, r by 2 ಇಂದ r by 3 ವೇರಿ ಆಗ್ತಾ ಇದೆ. So therefore this is equal to, so J is equal to, what is current density? It is A into R square. ಮತ್ತೆ area, so it is a wire anta helidare. So therefore area of the wire is given by what? 2 pi r. ಇಲ್ಲಿ with respect to DA ಇರೋದ್ರಿಂದ ನಾವಿಲ್ಲಿ DR ಇದೆ ಇಲ್ಲಿ. So therefore ಇಲ್ಲಿ DR ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗತ್ತೆ. ಆಲ್ರೆಡಿ ನೀವು ಇಂಟಿಗ್ರೇಷನ್ ಅನ್ನ ಕಲ್ತಿರ್ತೀರಾ. So you know why we need to multiply here DR. So this is D by 3 and R by 3, and here we have R divided by 2. That is, the integration limit is what? R by 3 to R by 2. Okay, so which is equal to, so il constant enide, we have the constant 2 pi A is constant and we need to integrate r into r square agate. So r square into dr. It is r square into dr. Okay, already a r square ide. So r square into r andre r cube agate. This becomes r cube. So r cube into dr. So let us integrate this one. Matte range enide r by 3 to r by 2. Yes. Yes, ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದಾ students, what is integration of x raised to n? What is integration of x raised to n?
n into x to the power of n minus 1 into t.
X raised to n plus 1 divided by n plus 1, correct? X raised to n plus 1 divided by n plus 1 ಅಂತ ಬರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ r ಪ್ಲೇಸ್ ಅಲ್ಲಿ x ಪ್ಲೇಸ್ ಅಲ್ಲಿ r ಇದೆ, ಮತ್ತೆ n ಪ್ಲೇಸ್ ಅಲ್ಲಿ 3 ಇದೆ. ಸೊ ದೇರ್ ಫೋರ್ ಇದೇನಾಗುತ್ತೆ, r ಟು ದ ಪವರ್ 3 plus 1 ಅಂದ್ರೆ 4 ಆಯ್ತು, ಡಿವೈಡೆಡ್ ಬೈ 3 plus 1 ಅಂದ್ರೆ 4 ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ದಿಸ್ ಬಿಕಮ್ಸ್ r raised to 4 divided by 4 ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು dr ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದೀವಿ. ಮತ್ತೆ ಇಲ್ಲಿ ಏನ್ ಲಿಮಿಟ್ ರೇಂಜ್ ಇದೆ r by 2 and the lower limit is r by 3. Now what we need to do is we just need to substitute r, small r ಏನಿದೆ ಆ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ನಾವು r by 2 ಮತ್ತೆ r by 3 ಅನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ಹಿಯರ್ ದ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ J is equal to 2 pi a ಅದೇ ರೀತಿಯಾಗಿ ಇಟ್ಕೊಳ್ಳಿ, ಡಿವೈಡೆಡ್ ಬೈ 4 ಕೂಡ ನಾನು ಹೊರಗೆ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. ಅಂಡ್ ಇನ್ಸೈಡ್ ದ ಬ್ರಾಕೆಟ್ ಇಟ್ ಇಸ್ r by 2 ಅಪ್ಪರ್ ಲಿಮಿಟ್ 4 minus lower limit r by 3 to the power of 4. Yes, so here you can see r by 4 common barutte, r to the power 4. r to the power now horgade tagolbodu. What we can do here, 2 pi into a divided by 4, and here we have r to the power 4 agatte. Illen ulitu 1 by 2 minus 1 by 3 ಮತ್ತೆ ಇದ್ರದ್ದು r 2 to the power 4 ಇದೆ, 3 to the power 4 ಅಂತ ಬರುತ್ತೆ. Yes, so please keep yourself mute. Okay, ಹಾಗಾದ್ರೆ 2 raised to 4, 2 2s are 4, 4 2s are 8, 8 2s are 16 minus 3 raised to 4. So if you simplify, we are getting option A, students. That is 65 pi a r raised to 4 divided by 2592. ನೀವು ಬೇಕಾದ್ರೆ simplify ಮಾಡಿ ನೋಡಬಹುದು. Here I have written the steps. Hope so you are understanding the steps. Otherwise ನಾನು ಇಲ್ಲಿ ಬರಿತೀನಿ ನೋಡಿ. That is integration of the current density. The current is equal to integration of J into dA. Why? Because we know that the current density is equal to current by area anta agate. So therefore current is equal to J into dA. We need to integrate this. Hauda? So current kelidare question alli. The current density value is given a raised to r square anta kottidare question alli into dA. So which is equal to ar square into dA anta andre it is 2 pi r into dr, that is the area of the given wire, and this is varying from the range of r by 3 to r by 2. So now the next step is what? Taking the constants out. So square r square barala, 2 pi a horgade baratte, and inside that we have r raised to cube divided by, not divided by, we need to integrate this one. R raised to r by 3, r by 2. So after integration, we will get it as like that. That is 2 pi a, steps anna copy madkoli. That is r raised to 4 divided by 4. Matte upper limit is r by 2, lower limit is r by 3. So after simplification, we are getting it as what? 65 pi a r raised to 4 divided by 2592. Copy down. Once you copy down, please message me in the chat box. I'll continue with the next question. Yes, completed students? Okay. So let us go for the next question. Yes, the next question is, for which of the following dependency of the drift velocity on electric field is Ohm's law obeyed? ಅಂದ್ರೆ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಮತ್ತೆ ದಟ್ ಇಸ್ ಯುವರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ರಿಲೇಷನ್ ಏನಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. when the Ohm's law is obeyed for that. VD is for drift velocity, E is the electric field, then VD is proportional to E square, VD is proportional to root of E, VD is proportional to 1 upon E. Is any idea? So ನೀವು ನೋಡ್ಬೇಕಂದ್ರೆ if you want to define that is mobility ಅನ್ನ ಡಿಫೈನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಪರ್ ಯೂನಿಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. Option A, option B. Okay, let's see the answer. It is option A. So why it is option A? Here you can see that. ಇಲ್ಲಿ ನೋಡಿ. See, we know that ನಮಗೆ ಕರೆಂಟ್ ಮತ್ತೆ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ರಿಲೇಷನ್ ಗೊತ್ತಿದೆ. I is equal to NEA VD. I is equal to NEA VD, or VD is equal to I divided by NEA ಅಂತ ಆಗುತ್ತೆ. ಹೌದಾ? What is current upon area? The current upon area is nothing but the current density divided by N into E. Divided by N into E. The current density can also be written in terms of conductivity, that is nothing but sigma into E divided by N into E, which is equal to VD anta agutte, which is equal to VD. So therefore our VD is directly proportional to the electric field anta helbodu. Option A is the correct answer. Yes, okay. So next question, a charged particle having drift velocity of 7.5 into 10 raised to minus 4 meter per second in electric field of 3 into 10 raised to minus 10 volt per meter, the mobility is, just now I told you the relation between the electric field and the mobility and the drift velocity. ಈಗಷ್ಟೇ ಹೇಳಿದೆ ನಾನು, mobility is equal to what? Drift velocity per unit electric field. So drift velocity ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? It is 7.5 into 10 raised to minus 4 divided by electric field ಎಷ್ಟಿದೆ students? It is 3 into 10 raised to minus 10. So please simplify and tell me what is the answer. B, Vedvati, yes? Yes, everyone is getting B answer? Yes, it is option B. That is VD upon E. VD value, B value. It is 2.5 into 10 raised to 6 meter square per volt per second. Correct. So let us go for the next question now. Okay. So you take a time and sort out this and tell me what is the answer. Match the column 1 with the column 2. So column 1 ನಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, Ohm's law is applicable to. Second one, Ohm's law is not applicable to. Alloys have. So first second column ಅಲ್ಲಿ ಮೆಟಲ್ಸ್ ಅಂತ ಇದೆ, ಗ್ರೇಟರ್ ರೆಸಿಸ್ಟಿವಿಟಿ, ಡಯೋಡ್ಸ್, ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಮತ್ತೆ ಸೆಮಿಕಂಡಕ್ಟರ್ಸ್ ಅಂತ ಇದೆ. ಇದ್ರ ಕೆಳಗಡೆ ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ABCD. ಸೊ ABCD ನೀವು ನೋಡಿದಾಗ ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಆಗಿದೆ? Yes, you take a time, just 1 second you take and tell me the answer. D, Sanjay. What about other students? D. B. D. Okay. So BD, I am getting the answer. B ನೋಡಿದ್ರೆ ಏನಿದೆ? That is Ohm's law is applicable to metals. Then Ohm's law is not applicable to diodes. Alloys have greater resistivity. B. D ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ? Ohm's law is applicable to. B ಬರುತ್ತಾ D ಬರುತ್ತಾ? D. Many are saying D. Ohm's law is applicable to diodes, electrolytes and solutions, sorry, semiconductors. It is option B is correct, students. How you can say that the Ohm's law is applicable to diodes and all? Ohm's law is applicable only for the metals, ಆಯ್ತಾ? So semiconductors ಗೆಲ್ಲ apply ಆಗಲ್ಲ. So ಒಂದ್ರ ಮೇಲೆನೆ ನೀವು ಅದನ್ನ ಹೇಳ್ಬೋದು. So option B is the correct answer. So option B ಪ್ರಕಾರ Ohm's law is applicable to metals. Ohm's law is not applicable to diodes, electrolytes and the semiconductors, and the alloys have the greater resistivity. Going for the next question. Yes. The IV characteristics shown in the figure. So ನೀವು ಇಲ್ಲಿ ಏನು ನೋಡ್ತಾ ಇದ್ದೀರಾ figure ಅಲ್ಲಿ IV characteristics ನೋಡ್ತಾ ಇದ್ದೀರಾ. The figure represents ohmic conductors, non-ohmic conductors, insulators, superconductors. The figure represents B, non-ohmic. Yes. Yes, very good. So it is option B, that is it represents the non-ohmic conductors, because ohmic conductors idre adenagate aa tara curve baralla, it will be a straight line. It will be a straight line. So this is IV characteristic is for what? Non-ohmic conductors. Go for the next question, students. The given figure shows IV characteristics of okay, this is the answer. Okay, next question is, which of the following is the correct for VI graph for the good conductor? Yes. ಸೊ ಕಂಡಕ್ಟರ್ಸ್ ಇದ್ರೆ ಇದರಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಫಿಗರ್ ಅಲ್ಲಿ ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗಿದೆ? ಸಿ, ಆಪ್ಷನ್ ಎ for good conductors. Yes. The graph between voltage does not obey exactly Ohm's law. It shows some deviation from the straight line. It shows some deviation from the straight line. So therefore option A is the correct answer. Okay. The next question, the range of resistivity for metals is. So resistivity for the metals, it will be less. So therefore, ನೀವು ಇದನ್ನ note down ಮಾಡ್ಕೊಳ್ಳಿ. The typical range of resistivity for the metal is 10 to the power minus 8 ohm meter to 10 raised to minus 6 ohm meter. So you can see this one. Options nodi. Option C is the correct answer. Okay. Moving towards the next question. This is not there. Leave it. Okay, you can see the question. Next question. The resistivity of alloy magnine is nearly independent of temperature, increases rapidly with increase in temperature, decreases with increase in temperature, decreases rapidly with decrease in temperature. Yes, read properly and tell me what is your answer. It is A, nearly independent of the temperature. Yes, very good. So that is what the resistivity of the alloy magnine is nearly independent of the temperature anta ಹೇಳ್ತೀವಿ. So ಯಾಕಂತ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ students, resistance is depending on temperature, length, area, but resistivity ಇದು ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. It does not depend on the temperature ಆಯ್ತು, ಇದು length ಆಯ್ತು, ಎದ್ರ ಮೇಲೆ ಕೂಡ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. So option A is the correct answer. So this you need to solve it now. The resistance of a heating element is 99 ohm at the room temperature. What is the temperature of the element if the resistance is found to be 116 ohm? The temperature coefficient of the material of the resistor is 1.7 into 10 raised to minus 4 per degree Celsius. So ಇದು ನಿನ್ನೆ ನಾನು ನಿಮಗೆ ಹೇಳ್ತಾ ಇದ್ದೆ, that is the coefficient of resistance ಮೇಲೆ alpha. So ಇಲ್ಲಿ alpha value ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. The temperature coefficient of the material is given by 1.7 into 10 raised to minus 4. This is the alpha value. ಮತ್ತೆ 2 ರೆಸಿಸ್ಟರ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. Hope so you remember the formula. Yesterday we have solved that. See. Copied on the question. I'll also tell you the answer. Otherwise, you can try it by yourself. R is equal to R naught into bracket 1 plus alpha delta T. Yes. So here you can see students. So R naught ಅನ್ನೋದೇನಿದೆ, that is the resistance. So that is given as 99 ohm. ಮತ್ತೆ T naught ಎಷ್ಟು ಹೇಳಿದ್ದಾರೆ, that is given as 27 degree Celsius. RT is given 116 ohm. ಮತ್ತೆ alpha value ಕೊಟ್ಟಿದ್ದಾರೆ temperature T. ಸೊ ಯಾವ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಅದೇನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ 116 ಆಗತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಯು ಕ್ಯಾನ್ ಸಿ ದ ಫಾರ್ಮುಲಾ. ನಾವು ನಿನ್ನೆ ಅಷ್ಟೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ದಟ್ ಇಸ್ ಆರ್ ಇಂಟು ಬ್ರಕೆಟ್ ಆರ್ ಇಂಟು ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ನಾಟ್ ಇಂಟು ಬ್ರಕೆಟ್ 1 ಪ್ಲಸ್ ಅಲ್ಫಾ ಟಿ ಮೈನಸ್ ಟಿ ನಾಟ್ ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಇಲ್ಲಿ ಆರ್ ಬದಲಾಗಿ ನಾವ್ ಇದನ್ನ ಆರ್ ಟಿ ಅಂತ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. ಅಂಡ್ ಅದು ಯಾವ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ 116 ಆಗತ್ತೆ, ದಟ್ ಟೆಂಪರೇಚರ್ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್. ಸೊ ಈ ಇಕ್ವೇಶನ್ ಅನ್ನ ನೀವು ಮಾಡಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಟಿ ಬೇಕಾಗಿರೋದು, ಹೌದಾ? ಸೊ ಏನಿದೆ ನೋಡಿ, ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ನಾಟ್, ನಾನು ಇನ್ನೆಷ್ಟೇ ಹೇಳಿದ್ದೆ ನಿಮ್ಗೆ, ಇಂಟು ಬ್ರಾಕೆಟ್ 1 ಪ್ಲಸ್ ಅಲ್ಫಾ ಇಂಟು ಟಿ ಮೈನಸ್ ಟಿ ನಾಟ್. ವಿ ರಿಕ್ವೈರ್ ಟಿ. ಸೊ ದೇರ್ ಫೋರ್ ಇದೇನಾಗತ್ತೆ, ಆರ್ ನಾಟ್ ಪ್ಲಸ್ ಆರ್ ನಾಟ್ ಇಂಟು ಅಲ್ಫಾ ಟಿ ಮೈನಸ್ ಟಿ ನಾಟ್. ಸೊ ದಿಸ್ ಇಸ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, therefore r minus r naught is equal to r naught into alpha t minus t naught. Correct? So what we can do, we can just take this r naught again on the other side. R naught ಮತ್ತೆ alpha ನ ಈ ಕಡೆ ತಗೊಳ್ಬಹುದು. That comes in the denominator. R naught into alpha which is equal to t minus t naught. ನಮಗ್ ಬೇಕಾಗಿರೋದು ಟಿ ಅಷ್ಟೇ. ಸೊ ಇಲ್ಲಿ ಏನ್ ಆನ್ಸರ್ ಬರುತ್ತೆ, ಪ್ಲಸ್ 27 you have to do. ಸೊ ಸೊಲ್ಯೂಷನ್ ನಿಮ್ ಮುಂದೆ ಇದೆ. ಆನ್ಸರ್ ಎಷ್ಟು ಬರುತ್ತೆ, ದಟ್ ಇಸ್ ಆಪ್ಷನ್ ಡಿ ಬರುತ್ತೆ. ಸೊ ಪ್ಲೀಸ್ ಕಾಪಿ ಡೌನ್ ದ ಸೊಲ್ಯೂಷನ್. ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್. If any doubt is there, you can ask students. Yes, completed. Yes, students, if completed, I'll go for the next question. Okay, the next question. Yes. the resistance of the wire in the platinum resistance thermometer at ice point is 5 ohm and at steam point is 5.25 ohm. When the thermometer is inserted in an unknown hot bath, its resistance is found to be. The resistance estaಗುತ್ತೆ? The resistance is found to be 5.5 ohm. The temperature of the hot bath is. Yes, so it is similar one. B 200. It's correct. So you can see here, students, it is almost same like the previous one. Same formula use ಮಾಡ್ತಾ ಇದೀವಿ. Alpha is equal to R100 minus R0 divided by R0 into 100. Let the temperature of the hot bath be T degree Celsius. So therefore RT is equal to R0 into bracket 1 plus alpha delta T. ಹಾಗಾದ್ರೆ alpha is equal to. So equation 1 ಮತ್ತೆ 2 ಅನ್ನ ನೋಡಿದಾಗ yes, ಮತ್ತೆ ಯಾರಿಗಾದ್ರೂ ಆನ್ಸರ್ ಬಂತ? ಆಪ್ಷನ್ ಬಿ is correct. Yes, copy down, students. Hope so you are understanding. After completion, please tell me. Yes, completed. You should be quick. Okay, I'm going for the next question. Yes, the next question is the resistance of wire in a heater at room temperature is 65 ohm. When the heater is connected to a 220 volt supply, the current settles after a few seconds to 2.8 ampere. What is the steady temperature of the wire? And the temperature coefficient is given. Alpha is equal to 1.7 into 10 raised to minus 4 degrees Celsius per degree Celsius. So it is also based on the temperature coefficient of resistance formula. So early you are getting answers. D. Okay. Yes, option D is the correct answer. So yaar question bardilla barಕೊಳ್ಳಿ, then I'll display the answer. So all the three questions ninne ನೀವು ಕೇಳಿದ್ರಿ ಅಂತ specifically I have taken this one. How they are asking the question, understand. Please understand the concept, how they are asking the question ಆಯ್ತಾ. Okay, take the solution also. Okay, the next question. A wire has a resistance of 2.5 at 28 degrees Celsius and a resistance of 2.9 ohm at 100 degrees Celsius. The temperature coefficient of resistivity of the material of the wire is. So the temperature coefficient anta andre en kelta idare? Alpha kelta idare. Here the resistance value is given, the temperature value is also given. You have to calculate just the resistivity of the material of the wire we are calculating. So with same formula only we will use, that is R2 or R is equal to R naught into bracket 1 plus alpha delta T. See the simplification, which step you will not understand, you can ask. R1 ಕೊಟ್ಟಿದ್ದಾರೆ, T1 ಕೊಟ್ಟಿದ್ದಾರೆ, R2 ಇದೆ, T2 ಇದೆ. So substitute the values, calculate the alpha. Yes. So R2 is equal to R1 plus R1 into bracket 1 plus alpha T2 minus T1. Therefore, alpha is equal to option C. Yes. So the graph based question we have, so figure A and figure B both are showing the variation of resistivity with temperature for some materials. Identify the type of these materials. So new question barkoli, this you will learn in actually theory. So I'll tell you the answer. First you take down the question. So both the figures are showing the variation of resistivity with temperature for some materials. How you can say option A or option B? Okay. Actually, here options are missing, I guess. Yes. So figure A and figure B both are showing the variation of resistivity with temperature for some material. Identify the type of the material. So ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಅಂದ್ರೆ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್. ಆಪ್ಷನ್ಸ್ ಇಲ್ಲಿ ಮಿಸ್ ಆಗಿಲ್ಲ, ಪ್ರಿಂಟ್ ಆಗಿಲ್ಲ. So the options are, the option A is, it is conductors and semiconductors. Option B, conductors and insulators. Option C, insulator and semiconductor. Option D, both conducts. Okay, whose number we need to add in the group, please tell in the end. Nim college ಹೆಸರು ಹಾಕಿ ನೀವು ಹೇಳಿ, so that it will be easy for us to add in the group. Okay. Yes, students. So here, whatever the figure you are observing, this is the conductors and for the semiconductors anta helbodu. That is option A is the correct answer. In conductors, due to increase in the temperature, the resistivity increases, and in semiconductors, it decreases exponentially. So therefore, it is the graph for conductor and the semiconductor anta helbodu. ನೀವು ಅಲ್ಲಿ ಗ್ರಾಫ್ ತೆಗೆದು ಜಸ್ಟ್ ಕೆಳಗಡೆ ಒಂದ್ ಕಡೆ ಕಂಡಕ್ಟರ್ ಅಂತ ತಗೊಳ್ಳಿ, ಮತ್ತೊಂದ್ ಕಡೆ semiconductors ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. Okay. The next question. A boy has two spare lights bulb. A boy has two spare light bulbs in his drawer. One he marked as 240 volt 100 watt, and the other one as 240 volt and the 60 watt. He tries to describe which of the following assertions are correct. So ಕೊಟ್ಟಿರೋ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಯಾವ್ದಿದೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. You just read yourself and tell me the answer. Option A ಏನ್ ಹೇಳ್ತಾ ಇದೆ, 60 watt bulb has more resistance and therefore burns less brightly. Less resistance ಇರೋದ್ರಿಂದ less bright ಇದೆ ಅಂತ. 100 watt bulb more resistance ಇರುತ್ತೆ, therefore burn more brightly. And the fourth one, 100 watt bulb has less resistance and therefore burns less brightly. Yes. Option A. Other students, what is your answer? Yes, it is option A. Correct it is. So when the same potential difference is there, the power will be same. The smaller resistance consumes greater power. Here 100 watt bulb has the less resistance. Therefore, it glows more brightly. So option A, Swati, yes. It is correct. Option A is correct. Okay, next question, nodi students. An electric heater is connected to the voltage supply. After few seconds, the current gets its steady value. Then its initial current will be, initial current ಏನಾಗತ್ತೆ when the electric heater is connected to the voltage supply. So voltage supply connect ಮಾಡಿದಾಗ initial currents will be what? Equal to its steady current, slightly higher than its steady current, slightly less than that its steady current, and the zero. Yes, your answer please. Zero. It is option B, students, that is slightly higher than its steady current. So ಈಗ electric heater ಅನ್ನ voltage supply connect ಮಾಡಿದಾಗ current gets its steady value. ಮತ್ತೆ initial current ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ slightly higher than its steady current. Option B is the correct answer. Okay. Go for the next question. So calculation is there. See, if voltage across the bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease is. So power calculation ide. Yes. So see here, the power is equal to V square upon R. As the resistance of the bulb is constant, delta P by P is equal to 2 delta V by V ಆಗತ್ತೆ. B option C ಬರುತ್ತೆ ನೋಡಿ. So therefore the percentage decrease in the power is given by delta P by P into 100, because percentage ಇರೋದ್ರಿಂದ multiply by 100 ಮಾಡಬೇಕು. ಹಾಗಾದ್ರೆ ಈ ಕಡೆ ಕೂಡ multiply by 100 ಆಗತ್ತೆ. 2 into the potential difference ಎಷ್ಟಾಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, it decreases by 2.5%. So therefore 2 into 2.5%, answer is option C, 5%. So see the answer. If any doubt is there, you can ask. Moving towards the next question, students. First we will go with this. Yes. Okay. So see, in a potentiometer, meter bridge is deleted, alla? Yes. Potentiometer is deleted, right? Or it is there? As I remember, meter bridge ಮತ್ತೆ potentiometer delete ಆಗಿತ್ತಲ್ಲ theoryಯಲ್ಲಿ? Or you have studied that? Yes, any one of you please reply. Okay. Yes. So forgot that. So we will not consider these questions because it will not come. I have some other questions, so I'll open that folder now. Just a minute. Yes, I hope you are able to see the questions. So let us simplify these questions. So first, go for fifth and sixth question, then I'll tell you the fourth question solution. So see the fifth question. The accurate measurement of EMF can be obtained by using multimeter, voltmeter, voltammeter, potentiometer. Yes, how you can measure the accurate EMF? C, B, accurate EMF is measured by using potentiometer. It is option D, students. It is option D. Okay. Go for the next question. Question number 6. The resistance of a wire at 300 Kelvin is found to be 0.3 ohm. If the temperature coefficient of resistance of the wire is 1.5 into 10 raised to minus 3 per Kelvin, the temperature at which the resistance becomes 0.6 ohm is. So already ನೀವು ಅದರ ಮೇಲೆ solve ಮಾಡಿದ್ರಿ ಈಗಷ್ಟೇ. So please use the resistance formula. R is equal to R naught into bracket 1 plus alpha delta T minus T naught. So use that formula. Temperature calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ತಾ ಇದ್ದಾರೆ T2. Yes, try. I'll solve and tell you how to do. A option. Okay, let's see. See here what you need to do, that is it is given R0 is equal to 0.3 ohm ಮತ್ತೆ RT is equal to 0.6 ohm ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ and alpha is equal to, it is given as 1.5 into 10 raised to minus 3. ಹೌದಾ? So we have the formula R is equal to R0 into bracket 1 plus alpha T minus T naught, and here we need to calculate, that is T value. So for that reason here substitute this one. This is 0.3 which is equal to R0 into bracket 1 plus alpha value is 1.5 into 10 raised to minus 3. Illen helidare avaru, that is the resistance is found to be 0.3 if the temperature coefficient of the resistance, the temperature at which the resistance becomes 0.6 ohm. The resistance of the wire is given as what? 300 Kelvin it is given. So Kelvin iddadana nan degree Celsius al tagondre it will be 27. So therefore multiply here, it is by 27. So now the second equation is RT is equal to R0 into bracket 1 plus alpha delta T. So ille en kottidare RT value 0.6 into R0 into bracket 1 plus 1.5 into 10 raised to minus 3 into T. Howda? So now what you need to do, you need to divide equation 2 by equation 1. So if you divide equation 2 by equation 1, you will get the value of C baratte. You will get the C. Answer will be 720 degree Celsius. So Kelvin al connect ಮಾಡಿದಾಗ 993 ಅಂತ ಆಗುತ್ತೆ ನೋಡಿ. Dividing equation 2 by 3 ಮಾಡಬೇಕು ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ. So therefore it is 0.6 divided by 0.2 which, sorry, 0.6 divided by 0.3 which is equal to R0 cancel ಆಗುತ್ತೆ. The remaining is what? 1 plus 1.5 into 10 raised to minus 3 into T divided by 1 plus 1.5 into 10 raised to minus 3 into 27. So 0.3 by 0.6 by 0.3 ಅಂತ ಅಂದ್ರೆ this is nothing but 2. Correct? So ಇದೇನಾಗತ್ತೆ? 2 into bracket 1 plus 1.5 into 10 raised to minus 3 into 27 ಒಂದ್ ಕಡೆ, ಮತ್ತೆ ಈ ಕಡೆ ಏನ್ ಬರುತ್ತೆ? 1 plus 1.5, this is 1 plus 1.5 into 10 raised to minus 3 into T. ಹೌದಾ? So this you need to simplify it for T. ಇಲ್ಲಿ 2 into 1 2 ಆಗತ್ತೆ, plus 2 into 1.5 is nothing but 81 into 10 raised to minus 3. ಇಲ್ಲಿ 27 ಕೂಡ multiply ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. And this side here it is 1 plus 1.5 into 10 raised to minus 3 into T. So you can do 2 minus 1 ಮಾಡ್ಬೋದು. Then here 1.5. 81 into 10 raised to minus 3 is 1.081 divided by 1.5 into 10 raised to minus 3, which is equal to 720 degree Celsius. So degree Celsius al bandide, option alli Kelvin al kottirodrinda 720 plus 273 is equal to 993 Kelvin. Yes. Check if any doubt is there, you can ask. Otherwise, the last question for today's class, that is the fourth question here. 3 resistors 1, 2, 3 ohm are connected to form a triangle. So ಏನ್ ಮಾಡ್ತಾ ಇದೆ, ಇದು triangle ಅನ್ನ form ಮಾಡ್ತಾ ಇದೆ. Across 3 ohm resistor, a 3 volt battery is connected. The current through 3 ohm resistor is. So we need to calculate the current through 3 ohm resistor. Okay, hope so you have copied that question number 6 solution. Okay, so fourth question nodana hagadre. That is 3 resistors are there forming a triangle. This is one resistor. And here we have the one more resistor. Here we have the one more resistor. This is 1 ohm. This is 2 ohm. This is 3 ohm. And this 3 ohm is connected across the 3 volt battery. Aita? So idanna A, B, C anta madana. now you can see 1 ಮತ್ತೆ 2 ohm ಏನಿದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ 1 ಮತ್ತೆ 2 ohm. This 1 and 2 ohm are connected in series. Okay, so 1 and 2 ohm are connected in series ಅಂತ ಅಂದ್ರೆ ನೀವು 10th ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಾ. The series resistors formula is what? R1 plus R2. So R1 is 1, R2 is 2, that is equal to 3 ohm ಅಂತ ಆಗುತ್ತೆ. RS will be 3 ohm. Okay. So now this 3 ohm is connected in parallel with your 3 ohm. So ಇದೇನಾಯ್ತು 1 ಮತ್ತೆ 2 ಈಗ parallel connection ಅಲ್ಲಿ it is with the 3 ohm. This is 3 volt battery. ಆಯ್ತಾ, ಈಗ ಏನಾಗುತ್ತೆ the effective resistance it will be 1 by Rp is equal to 1 by R1 plus 1 by R2 which is equal to 1 by 3 plus 1 by 3. So 1 by 3 plus 1 by 3 is nothing but 2 by 3, but it is 1 by Rp. So ನಂಗೆ ಬರೀ Rp ಬೇಕಾಗಿರೋದ್ರಿಂದ ಇದೇನಾಗುತ್ತೆ 3 divided by 2 ಅಂತ ಆಗುತ್ತೆ. It is 3 divided by 2. Okay, so therefore what they are asking the current through 3 ohm resistor. So before calculating the current through 3 ohm resistor, first ಏನ್ ಮಾಡೋಣ, current through the circuit. So current through the circuit ಏನ್ ಬರುತ್ತೆ, that current through the circuit is equal to 3 divided by 3 by 2. ಯಾಕಂತಂದ್ರೆ ಓಮ್ಸ್ ಲಾ ಪ್ರಕಾರ ಆಯ್ತಾ, that is V is equal to I into R, current I is equal to V by R. So V is how much? 3 volt. The effective resistance is 3 by 2. So therefore 3 divided by 3 by 2. ಇದೇನಾಗುತ್ತೆ 6 divided by 3. That is nothing but 2 ampere. This is the current through the circuit. ಇದೇನ್ ಬಂತು, current through the circuit ಬಂತು. Now for across the 3 ohm resistor. Last step, across 3 ohm resistor is, that is I1 is equal to the current through the circuit into the resistors divided by 3 ohm plus 3 ohm. That is nothing but 3 plus 3 is 6. 6 by 6 is 1. So therefore the answer is option B. Option B ಬರುತ್ತೆ. Yes, check. If any doubt is there, you can ask students. So copy down. We will meet in the next class. Okay, we will meet in the next class. Thank you.